Here we go. Okay, this is number 8 on page 204. Number 8, page 204, lesson 4.3. Use analytic methods to find the intervals in which the function is increasing, decreasing, concave up, concave down, local extreme values, and inflection points. Support your answer graphically. So, to figure out when it's increasing and decreasing, we're going to do the first derivative. So the first derivative would be what?
6x squared.
Negative 6x squared plus what? 12x. Now what you're going to want to do is, if you can, factor that expression. So I'm going to factor out a negative 6x out of both of those terms, which would leave me with x minus 2. Just dividing each term by negative 6x. Now you should be able to see what values of x will make the derivative come out to 0. I'm going to make a number line chart. So what two numbers would make this derivative come out to 0? 0 and 2. So when x is 0 and when x is 2, this derivative would come out to 0. Now we're going to pick some test values. Pick a number smaller than 0, like say negative 10. Put negative 10 in here, you're going to get a positive. Put negative 10 in here, you're going to get negative. Positive times a negative, negative. Pick any number between 0 and 2. Let's pick 1. Put a 1 in here, you get negative 6. Put a 1 in here, you get negative 1. Negative times negative, positive. Oh. Pick a number bigger than 2, like 10. Put it in here, you get a negative. Put it in here, you get a positive. Negative times a positive, negative. Any questions about how I was doing that? Okay, now let's try to make a sketch of the graph of y. Sketch of y. So this means that the original graph is going to have negative slope or be decreasing. So the graph's going to decrease until it gets to 0. At 0, it's going to have a slope of 0. Positive derivative means it's going to increase until it gets to 2, where it's going to have a slope of 0 again, and then it's going to have negative slope or decrease again. So now we can answer quite a few of our questions, because part A asks for when the function is doing what? Increasing. So it's increasing between what and what? 0 and 2. Yep, and we consider at 0 and at 2, we would say the function is both increasing and decreasing at each of those points. So we're going to include those points using the square bracket. Decreasing, be decreasing at the left, far left of the graph, so from negative infinity to 0. Include 0. Also, so use union symbol, from 2 to infinity and be decreasing there also. Include the 2. Any questions about that? Okay, now when it asks for concave up, concave down, and points of inflection, we have to use the second derivative to figure that out. But part E asks for local extreme values. We can do part E right now.
So, when we're supposed to support graphically, that's okay?
This is okay. Yeah. If you want to type it on your calculator, you can. But if you just make this sketch, that's acceptable to me. Okay, the local extreme values, well, looks like there's a local min right here at 0, right? But to actually find the local minimum, what do I have to do with that 0?
Plug it original.
Plug it in the original. So if I plug 0 in here, what do I get for a y coordinate?
Negative.
All right. So local min of y equal negative 3 occurs at x equals 0. Local max of, so we plug 2 into the original equation. So if you plug 2 in here, you get negative 16. Plug 2 in here, you get plus 24, so that's 8. Minus 3 is 5. So a local max of y equal 5 occurs at x equal 2. So you can get you can find out when the function is increasing, decreasing, and you can find its local mins and maxes all using the first derivative. Any questions about that? Okay. Second derivative. The second derivative is just the derivative of the first derivative. So y double prime, what's the derivative of negative 6x squared?
Negative 12x.
Negative 12x. What's the derivative of 12x? So negative 12x plus 12. Again, let's factor out. In this case, let's factor out a 12. You could do 12 or negative 12. Make another number line. This time our number line is going to represent the second derivative. You want to make sure you label your number lines. The top numbers will be the second derivative, the bottom number will be your x's. What number would make the second derivative come out to 0? 1, x equal 1. Okay? Pick a number smaller than 1, like 0. If you put 0 in here, what type of an answer do you get?
Positive.
Positive, good. Now pick a number bigger than 1, like 2. Put 2 in here, what type of an answer do you get?
Negative.
What does a positive second derivative tell us about the original function? Concave up, good. So this function switches from concave up to concave down. Let's draw that a little bit better. Notice it looks very similar to this graph over here. It's the same graph at a point of inflection right there. How do I find the y-coordinate of my point of inflection? Plug 1 in the original equation. Plug 1 into here, you're going to get negative 2, plus you plug 1 in here is 6, so negative 2 plus 6 is 4, minus 3 is 1. So, we've got a point of inflection at 1, 1. We have concave up from negative infinity to 1. Now, we do not include the 1 when we do concave up and down. Okay? Concave up